Hello everyone, welcome back. We're going to continue with the different packaging equipments and machinery that we have been discussing this whole week. We've already gone through the vacuum packaging machine, CA and MA packaging machines, gas packaging machines. These were quite similar. We talked about another technology on seal and shrink packaging machine, form, fill, seal machine. And the last one we're going to discuss this week is the aseptic packaging machine. Now, you're already familiar with this topic because we've discussed this in the last module on aseptic packaging. A quick recap, the definition is filling the product which is sterile in a packaging material which is again sterile, and these two are brought together in a sterile environment. So naturally, once you hermetically seal it, hermetically means you do not allow the gas to enter into the package. If it's hermetically sealed, you can increase the shelf life of the product to at least 1 to 2 years without any cold storage, which is a great advantage in the case of aseptic packaging. You're very familiar with the long shelf life milk that is available today in the market, and this is especially done with the aseptic packaging technology. So in the heating or the sterilization of the product, generally they use UHT, which is ultra high temperature, or the HTST, which is the high temperature short time method. And both these methods helps in sterilizing a product, and the advantage of this is taken by packing it in a sterile environment in a sterile packaging material. So you also know there's nothing called 100% sterility. You can only attain commercial sterility, that is absence of organisms that can reproduce in the normal conditions. Okay? So these organisms, suppose if they are present, they do not reproduce under normal conditions of storage. When we come on to the packaging systems that are used, basically the aseptic packaging systems, there are 4 important criteria that you have to meet. Number 1, the system must be able to be connected to the processing system in a manner that enables aseptic transfer of the product to take place. It's not possible to keep changing your machinery all the time. So see that the packaging system is compatible to the processing system. Number 2, it must be able to effectively be sterilized before use. The packaging system should be effectively sterilized. Number 3, it should be able to carry out filling, sealing, and any transfer operation in a sterile environment. It's not every package that you can seal and fill in the same machine. So see that your packaging machine is compatible with the packaging material used. And number 4, you must be able to clean it properly after use. So these are the categories of food systems that you use in an aseptic packaging system. Cans, very commonly used for your aseptic packaging. Cartons, your Tetra Paks are used for aseptic packaging. Bottles can be used for aseptic packaging. Pouches and cups. So these are the usual aseptic packaging systems that are used in the industry. Now when you come to the carton system that you have, there are 4 basic liners that you have in the package itself. These are 4 basic materials. Some of these materials are repeated so that you get even 6 layers. It only increases the barrier properties of the packaging material. Paper board, which is unbleached or bleached. And the paper board is the one that gives you the shape and the stability. You can shape it in anything, any way you want just because of the paper board. And it gives you the rigidity and the decorations that you need to add on to your Tetra Paks. The second layer is your PE. The PE film is very important because that number 1 importance is the heat sealing. Always remember, in most of the packaging systems, it is the LDP which is the inner layer. So once you heat seal, LDP is heat sealable. So it is always kept as the inner layer so that it can be sealed. It's also a moisture barrier and it has got adhesive effects. Aluminium foil is one of the most important layers that you can have in a Tetra Pak because that is one of the best gas barriers. So once you have an aluminium foil, it prevents the gas from coming in or leaving the package, which is very important because a gas barrier property is one of the most important property in a hermetically sealed container. And these can be repeated, like I said, to make 6 layers or more if you require. So in the carton type, the first system that you have is a form, fill, seal carton. You all are all familiar with this system where the carton is formed in the line itself it is sealed, filled with the product, and finally open portion is sealed again. So let's look at the flow chart. The printed and creased package material roll is taken. A longitudinal strip is made. Usually they use PET or EVOH. You sterilize the packaging material. Once it's sterilized and formed, the sterilized product comes into it and it is finally sealed. Everything is done in a very sterile environment. How to create a sterile environment in a room? Generally they use UV light. So you would not have a personnel coming in and going out in a system where the aseptic packaging takes place. It will be a room where UV light is produced to create sterile environment. The package, like I said, is sterilized separately and the product is filled in it in a form, fill, seal, carton system. There are different ways in which you can sterilize your form, fill, seal cartons. One of the methods is called the wetting method and one is called a deep bath system. Both these cases, you're sterilizing your packaging material. In the wetting system, generally they use hydrogen peroxide is the containing wetting agent is used. And that is applied on the inner layer of the material surface. And then you pass the coated material through rollers and that will squeeze out the excess liquid. And once it is sterilized with your hydrogen peroxide, it's allowed to heat buried in a tubular heater. The hydrogen peroxide will be evaporated and this sterilized package can be used for your filling. The second method of sterilizing your packaging material is called a deep bath system. Here, the packaging material is passed through a deep bath. It's just like a tub with your solution. You pass it through the bath which contains the hydrogen peroxide, which is around 35%, at a temperature of 70 degrees. Now at this temperature and this concentration, the residence time is usually 6 seconds. So you pass the packaging web through the bath, keep it for around 6 seconds, bring it out, and just like your wetting system, you allow it. There are squeeze rolls which will remove the excess hydrogen peroxide and both the sides are heated with air at a temperature of 125 degrees centigrade, which evaporates any of the peroxide residues. And this sterilized packaging material is then used for filling. So basically two methods, wet method or the wetting system, and you have the deep bath system. One you apply, one you pass through the bath. Now there are prefabricated cartons that are usually used or preformed. You must have seen the webs of cartons which have got the crease where you can fold it. This also comes in many of your craft papers where the crease is formed and children just have to fold it. Same way you have preformed cartons which are finely shaped in the filler. The top seaming is formed. Top seam is the open ends are brought together. Top seam is formed and sealing is done. It is sterilized in one of the methods that we just talked about. Again, it is filled with the product. The top portion is folded. Top is then sealed and you fold the protruding ears. Protruding ears are the two ends that you see in your Tetra Pak. Any beverages that you see in your Tetra Pak, you might have seen the protruding ears. That is done in the end. So there are ways in which you can sterilize your preformed cartons also. This is done inside the surface. It is sterilized with 35% hydrogen peroxide and the delivery is through a fine vapor. You give the hydrogen peroxide in the form of a fine vapor or spray in hot air and that gets condensed on the surface. And then you need to remove the excess hydrogen peroxide after sterilization. And that is done by using a hot air jet of around 170 to 200 degrees centigrade. Or another method, if you do not want to use hot air, is irradiation. You irradiate this sterilized carton for 10 seconds with high intensity of UV radiation and then you can finally remove it by hot air jets. This ensures that all the hydrogen peroxide residues are removed. Let's look at the can systems that we use. The can system will use superheated steam at temperatures of 225 degrees centigrade for around 40 seconds for sterilization. So basically there are three types of cans. You can have tin plates, you can have the ECCS or the aluminum cans. The size is around, you can have 125 milliliters to 22 liters. So that is the range in which you can have your can system size. And this superheated steam is used to maintain asepsis. Asepsis is absence of infection or microbes that cause infections. There is a less headspace because of this, because they use the superheated steam. And either sterile air or nitrogen is blown in this headspace. Why? To prevent excessive vacuum from developing there. And you can use composite cans also in this aseptic can system. Now there are different can types based on their method of construction. You have a 3-piece cans, 2-piece cans. I'm not repeating the whole thing because the whole thing has been done in your second module already. So in 3-piece can, you have your body, which is seamed in the center, and you have the top portion and the bottom portion, which makes it a 3-piece can. While in the 2-piece, actually it's made from a single body, a single sheet. You can use a draw or redrawn method, and you get a cup, you draw it and redraw it. So actually this whole thing, the body and the bottom is one piece. Then you just have to cover it with the top piece. So it's a 2-piece can. So it does not have a side seam. That you should remember. In a 3-piece can, you have a side seam. In a 2-piece can, you will not have a side seam. And the side seam, if they have it in the 3-piece can, it's usually welded, or it can be soldered with tin. So rigid aluminium cans that you see in your carbonated beverages that you'll have. So your aluminium cans that you use mainly for your carbonated beverages, your Pepsis or your Fantas or your 7-Ups, those are usually the 2-piece cans. Okay, you might be very familiar that they do not have a side seam. They are drawn from the same sheet, and then you have the top cover. So this is usually they have drawn or redrawn, or it's called the drawing and the ironing technique. I'm sure you all must have studied this in the other modules, and this is just a recap of it. So this is 3-piece can where you have a side seam. You can see that the seaming is important, and you have the top portion. So the first 3-piece can includes your cylindrical body, your top lid, and your bottom portion. These are the typical can sizes that we use in the food industry, and these are the types that you have. You've got an open top can. You must have seen these are pilfer proof. What are pilfer proofing? Tamper proof. It means if they are tampered with, you will know if the can has been opened. These are easy to fill and handle. You have them as big capacities up to 100 grams to 4.5 liters. Used for vegetables and fruits and meat products. You have a key opening cans with the reclosure. Generally, you have the key, you can open the lid. At the same time, once it's open, you have these plastic lids that can be used for a reclosure. And this is used for coffee and nuts. And after the key has been used once, you cannot put the lid again. You need to have a second lid, which is usually made of some kind of plastic, and it is flexible, so it can be closed. You might also have cans which are key opening cans without reclosure. This is also very common that you see in your condensed milks, where you can actually open it, but at the same time you might not have your covers to it. You have to transfer it to another container. So the can tins have to be removed without much damage to another container for storage. Another is called a slip lid can. Generally they use it for cocoa and other dry product. It's a simple reclosure method. You can open it at the same time close it after it's used. The cans are one system that they use for aseptic packaging. Another system they use is bottles. Glass is the ones that they use for your bottle system. Now sterilization here is either by saturated steam under pressure or dry heat. You can either have it wet steam or under dry heat. Dry heat, you need to have extended cooling to prevent breakage and thermal shock. This is not a very much accepted method. Now in the bottle system, other than your glass, you can also have your plastics. Now there are 4 different systems that are in use. One is you can have your non-sterile bottoms. So these non-sterile bottles, after they are blown, they are conveyed to the sterile chambers. Here they are sprayed with your hydrogen peroxide generally, and the peroxide residues are evaporated. You can even use PAA for your sterilization, and that is rinsed with sterile water. Or you can, another method of having your plastic bottles sterilized is sterile blown bottles. Here the bottles are extruded and blown with sterile air. The whole system, while you're forming your bottles itself, sterile air is used. It is sealed under sterile conditions, and it's introduced to a chamber where hydrogen peroxide is sprayed on it. So you can either have it as non-sterile and then make it sterile, or while forming the bottle itself, you can sterilize it and then form it. Third way is sterilization of preformed containers. Here dry contamination is done without water. Here 5 to 15 milligrams of hydrogen peroxide is done per preform, and these vapors after sterilization is applied, they're finally heated to remove any residues. You can also have single station blowing, filling, sealing. That means all the operations like your extrusion, blow molding, bottle filling, sealing, everything takes place in a single mode. This is a very difficult one, but it's a very efficient system. Sterility is maintained by high temperature and the sterile air that is there in the system itself. They use HDP, PP or PETG for this kind of operations. So we talked about cans, we talked about bottles, and you can also have your commonly used for your aseptic packaging, your sachets and your pouch system. So in this, you form, fill, seal system can be used. Vertical system is used to operate in a sterile chamber. The packaging material is passed, like we said, like we discussed earlier, through 35% of hydrogen peroxide, drained, and then it is dried in hot air to remove, or it is irradiated under UV to remove the excess of the residuals. The laminate of LLDP with EVOH is usually used for these kind of systems. You should understand these are EVOHs added for the extra barrier properties that it can offer. And then fin sealing is done on all sides. Fin sealing we've already discussed, where the end seal protrudes out from the main body. So you can actually do when you open any packages that you all have, the fin seal helps in the opening. So this sachet and the pouch system itself can be of different types. You can have bag and pouch systems. Here, sterile enclosed product, they transfer path. The inner bag is completely sterilized using a fill process. You have a bag system which is 1.5 to even 1400 liters. Now in the sachet and pouch system itself, you've got something called a bag and box system, where you have the product filled in a bag and this is finally packed in a box which is printed for appeal. In this case, what they do is the sterilized enclosed powder is they transfer path and the inner bag is completely sterilized during the fill process. Okay, so the product is put into the inner bag. The bag size can be 1.5 to 1400 ml and the EVOH and metallized PET is the barrier in this case. It's very important, like we said, to have a good barrier inner layer, because that helps in increasing the shelf life of the product. Sterilization with filling is accomplished by steam. When you're filling the product and you want sterilization to take place during the filling, you need to use steam. A double membrane in the bags will ensure it is completely tamper-free. And after filling, this bag with the products is fitted into a paperboard box. You have another system which is called lay flat tubing system. Here, the blow film polymer is found in the form of a lay flat tubing. Only transfer seal is required to form the bag. So you have it in the tube system, you just need to have your transfer seal. Inside it is sterile because of the high temperature of extrusion. And this tube is then fed from a reel to a sterile chamber and this ensures sterilization. The chamber itself is sterile, then you can fill your product and seal it. But this is unlike your flat system, this is a lay flat tubing system. Cups are also used for aseptic packaging. In the cups, you have pre-formed plastic cups. Usually it's made of HIPS or PP, polystyrene or polypropylene. You can even have your cup system as your aseptic packaging. I'll show you a video how cups can be sealed. So here you can use pre-formed plastic cups, usually made of high impact polystyrene, which is HIPS, and polypropylene, PP. Or you can use co-extruded multi-layered polymers. So all these are good barrier properties. Films are used. The cup is fed into the conveyor belt in a sterile tunnel. And generally they spray hydrogen peroxide 35% for 3 seconds. Remove excess of the hydrogen peroxide by heating at 400 degrees by compressed hot air. And once the sterilization is complete, then the material is sterilized and you can go in for your filling of the sterilized product. In the form fill seal cups, where the cups are formed in the system itself, you fill it with the sterilized product and then you seal it aseptically. Here the material is fed from a roll into a thermoformer. A thermoformer, as you know, you can have a web where a mold comes in and under heat you can get any shape of tray that you want. It's called a thermoform tray or the thermoformed cups. And these thermoformed cups can be you can have multiple cups in a single web. So once this is done, there is a lot of advantage to this. One is there is less cost, simplified handling, high output because you're creating multiple cups at the same time. You have higher output, smaller storage requirements and maximum sterility. Now sterilization of the web is done throughout using this hydrogen peroxide bath of 35%. Residence time generally 15 seconds and you can use air knives and heats. Everything that you need to cut out these cups have to be sterilized also. And the containers, once they're formed, sterilized, they're cooled. and the sterilization of lid is done separately. This sterilized cups come in, filled in with the sterilized product, and then the sterilized lids are placed on top of it, and it is done in an aseptic condition. So integrity testing, one of the most important thing now is the seal integrity. If the seal has even a small pinpoint hole formed, the aseptic packaging system will fail. So the seal integrity, if you want to see if every portion is completely sealed, it is always hermetically sealed, there is no ingress of or gas at any point. So there are different ways of doing this. One of it is by biotesting. You can use electrolytic testing, dye penetration or bubble testings to see if there is any pinpoint holes anywhere. Another way is you also use non-destructive. You don't have to open it or anything. These are all innovative techniques that are used where you can test if it is completely sealed, or you can test the integrity of the seal without destruction. You don't have to break the seal, or you break the product and check anything. This is based on a stimulus response technique. So the stimulus they give is generally they give pressure, or they can use trace of carbon dioxide or helium or ultrasound. All this will help you to find out if the seal is not in place properly. You can easily find out. These are non-destructive tests to test for your seal integrity. Another one is you can use response, that is the package movement, pressure change or trace gas detection can be done. And all this will help you to find out if your seal is properly in place. So we've come to the end of the session where we discussed in detail on aseptic packaging. We know now that aseptic packaging, if done properly, can increase the shelf life dramatically, even up to 1 to 2 years. So that is actually helping to reduce the cost in terms of chilling or storage or refrigeration temperatures that is needed at this time. I hope you got a fairly good idea of this technique. I'll meet you in the next session. Thank you. Take care till then.